What makes data special? The module 2 will cover the four most important components: spatial data, understanding spatial features, coordinate systems, spatial versus tabular data sets. And before starting about what is geospatial data, I just want to remind about the web mapping and the structure of the web mapping, which we actually the overall purpose of this course is. So if you see the component is the data server, so data server is actually is containing all those geospatial or spatial data sets, which we are going to be talked about now. But other components we will discuss in the next coming modules. Just want to be just remind you that this is the overall plan, but what we are going to talk about is which is usually not visible on this structure diagram. And if you want to see overall and the web mapping versus geospatial, so in this table you can see the different kind of aspects, purpose, and then we have open source versus proprietary solutions, and how you want to develop the front end, where you have a map data, and what are the different kind of data storage options you have, how you want to making the user interface, and finally the customization options when you have more complex situations. So here in this scenario, the most important thing is while you're building the web mapping, so what is the geospatial data sets, how it look like, and how we will generate it. And then we need to be understand a little bit more about the data set. So geospatial data is any information that has a geographical reference, enabling it to be mapped and analyzed in relation to Earth's surface. So there are three different components which we need to be have to be keep in mind. First one is about the location or geometric, so it's expressed as coordinates, which could be a latitude, longitude, and different ways to explain the coordinates, or the location, which could be the addresses or any other coordinate systems. Attributes, which is what, and this is descriptive information. So if you have a location, so you want to be describe what kind of location is, and any other descriptive information you want to attach with it. And the relationship, so is there any topological connections, like this building is within the school catchment area, or temporal dynamics, like the PM 2.5 peaks at 9 a.m. near the schools. Those kind of situations, those informations define those the the, the kind of the data set, geospatial data sets. Okay, so when we talked about the types, so there are different types of geospatial data sets we normally deal with it. So most popular is the vector data, which is we normally describe with points, lines, and polygons, and could be the examples of different kind of things we will discuss in the next coming slides. Rasters is pixels, and the use is slightly different as compared to when you will see the vector data sets. So there's another type, which is a network, or we call it a graph, which is basically the combination of the nodes and edges. Normally we use for the network building and topology, building those kind of transportation routing and the utility grids and the power distribution, power losses, leakages, pipe leakages, those kind of things could be used for the network data sets. And clouds, point cloud, which is could be a 3D LiDAR data, which is light detection and ranging, or then SFM, which is the structure from motion technologies, which is basically the 2D images from different angles and creating the 3D points. Those are another type of the data which we use and when we're dealing with the special data types. Okay, I want to tell you a tale of vector rosters and graph in a different way. So each had unique power to capture the world in their own way. So this story is Vector was an artist who sketched reality using points, lines, and polygons. So points marked as exact locations, lines trace rivers, roads, and power grids, polygons fenced off cities, forests, and even your backyard. His superpowers include the pinpoint accuracy for addresses, land parcels, and infrastructure, and also giving you the power to editing the shapes easily. But be aware of any tiny gap in a polygon unclosed ring could make a lake disappear or overall invalid your data sets. So this is something which you need to be understand and then also be aware of the coordinate system which one you are using. So the real world mission, for example, help Karachi's city planners map slums using OpenStreet polygons or mapping every hospital in Pakistan with OpenStreetMap. The raster. I capture reality pixel by pixel. Raster capture reality in a grid of colored cells, which we call it pixels. It could be the satellite based, which can show you the forest in green, desert in brown, or the ocean in the blue. Then you have elevation models revealing mountains and valleys, weather forecasts, predicted rain with temperature grids. So her superpower showing continuous data, for example, air pollution, rainfall, landscape, perfect for AI ML models, training the models to spot deforestation, detect crop disease. But be aware, zooming too much reveal blocky pixels where the road at. A single cloud could ruin her perfect snapshot. So snaps satellite images are useless if the cloud coverage is there. So predict large heat waves using NASA's 30-meter thermal rasters or tracking glacier melt in Himalayas with NASA Landsat dataset. So these are the real world missions you can consider when you're talking about the raster dataset. Graph, the invisible connector. I wave the words hidden networks. So graph was a hidden third sibling waving roads, rivers, and Wi-Fi signals into a network. Nodes were intersections, edges were connections. For example, highway, fiber optics, cable, social connections as well. His superpower, routing ambulances through traffic, calculating shortest and best routes, modeling how electricity flows in a grid, or in case of water, gas through the pipelines. But be aware, a missing bridge link could trap travelers forever, so it causes system failure. And in case of the real world mission, optimize Pakistan's gas pipelines to prevent winter shortages. When we put these three things together, the trial's greatest adventure. In case of the disaster response, when floods hit Pakistan, Vector mapped evacuation zones in the form of polygons. Raster predicted water spread using the elevation model and rainfall forecast, and Graph found safe route using the road network, avoiding the blocked pathways. So together, they saved thousands. So why coders were silent heroes? Because they built system that automatically updates evacuation plans as new data arrives. So their tools silently guide rescuers through the chaos via phones and the dashboards they built. Spatial data does not magically appear. It's collected through sensors, surveys, and algorithms. In case of vector data, so which capturing the discrete objects, it comes through the different methods, including GPS survey, which is a field work, you mostly in case of the handheld devices or differential GPS, and usually collecting the points, or in case of the connecting the points to create those lines and polygons. In case of the aerial imagery and AI tools, the classical example is extracting the building footprints using those satellite imagery or aerial photographs or drone data sets and using the AI-based algorithm to automatically trace those images. So buildings are like a continuous process. So this process will be continue. So as we have a new imagery and data sets from the different sensors, so this process will be continuously update those data sets. And of course, the government records, which is the city planner, digitized land parcels and other things, can be used in the property boundaries. So for example, so in nutshell, if you want to see the workflow for that, a surveyor walks through a Karachi slum area with a high resolution, high precision GPS, for example, 10 centimeter, and each home's corner is recorded as a point. So software, for example, QGIS, connects points into polygons for housing blocks. Okay, raster data, grids of measurements, the methods, satellite data sets, LiDAR scans, weather stations. There are different sources where we can capture the data sets, and it's comes in a different formats and different types. And the workflow, for example, is Sentinel-2 satellite images of Pakistan, for example, 10 meter pixel resolution. Software calculates NDVI, which is the vegetation index, from red or infrared bands, and output is a geotap file showing forest coverage changes. In terms of graph data, which is the modeling networks, so methods could be the OpenStreetMap, where the volunteers can digitize the road and infrastructure in the form of the nodes and edges, and Internet of Things sensors like smart traffic lights count vehicles, congestion heat maps can be produced as the outcome of this. Social media APIs, for example, Twitter, geotags, and can help to analyze the mobility, and which is also the human movement graphs. The workflow in this case could be the OpenStreetMap contributors trace streets as line features, and you can use some tools. For example, the GeoPanda converts roads into graph, like into the intersections and the streets and edges, those kind of things. And then the graph powers basically route optimization for urban areas. So in the web mapping, we talked about the geospatial data, which is basically the start of any web development. But when you developing a front end, so you have some kind of visualizations. So next slides are basically to give you the idea how normally we use visualization to show different kind of geospatial data data or features and some related elements on those front end. So this is a research paper, very interesting literature review. Basically, they compare 8 different applications. You can see those names, including the Google Maps and the MapQuest, and those are included. And they try to compare their different aspects, including map key, scale, map layout, navigation elements, labels, and analytical tools these websites or these applications are using. So you can have idea how the developers are basically using the geospatial data to in different kind of application. This slide giving the example how these 8 applications are displaying polygon, line, and point features on their website. So the polygons include buildings, forest, field, park, and water body. Then you can see how these different applications are using different kind of color scheme shades. In terms of the lines, mostly the highway, road, railway, river, and state boundary. And the points, you can see the city, whether the capital city, hospital, parking signs, and any peaks. So these are the different ways to use those special data sets when you are developing the front end or visualization for your web mapping. Scale bars are another way. You can see that using different styles of the scale bar as well. Map layout. So these applications have a different layout, how they want to be put those things together, where you have the map, search, different kind of legends, and those different elements on those web maps. They have navigation elements as well, so which varies from one application to other applications. Some can give you the like the calculate the distance or using their vehicles, pedestrian, bicycle. So they have a different kind of features which can help to do the navigation. And in terms of the labels, they use different kind of colors, font types, styles. Those are all you can see, and they have a different kind of label as well. So label for the polygons, so points, linear features, and those kind of things. You can see the different variety they're using. This table present a analytical tools and available in different web applications. So that include route planning, 3D view, distance measurement, data import, exports, option, and you can print out, you can share the map, or if any errors, so you can report it not. So you can see they have a different functionalities available on these web applications. So this week, you see I covered mostly the first two components, and next talk will be more on coordinate systems, and we will try to wrap up the spatial data, and then we will move to the next module. Thanks for watching.